Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a silicon bar is doped with donor impurities Nd is equal to 2.25 times 10 to the power of 15 atoms per centimeter cube. Given the intrinsic carrier concentration of silicon at T is equal to 300 Kelvin is 1.5 times 10 to the power of 10 centimeter power minus 3. Assuming complete impurity ionization, the equilibrium electron and hole concentration are what? So here the question is asking for the electron and hole concentrations. Okay, initially they have mentioned this is doped with donor impurities. So whenever they say like doped with donor impurities, it means this is an n-type semiconductor. N-type semiconductor mean the majority is going to be electrons and the minority is going to be holes. So we can say Nn is for electrons, that's going to be the majority. And also in the question they have mentioned this is going through complete impurity ionization. It means Nn is approximately equal to Nd. Okay, and that value is given right here. This is the donors added, right? So that's going to be the Nd. That is 2.25 times 10 to the power of 15. 2.25 times 10 to the power of 15 atoms per centimeter cube. So this is going to be the electron concentration. Now we have to find out the holes concentration. So this is majority and minority are holes. To find the minority, we have to use the mass action law. Mass action law says that if you multiply electrons times total number of electrons times total number of holes, you will get intrinsic carrier concentration square. So this is equal. Now if we rearrange it here, we can write this one as Nn. Since this is an n-type semiconductor, we can put a suffix like this: Nn Pn is equal to Ni square. Then here we are trying to find Nn is already there. We found that one already. Now we are interested in finding Pn. Pn is going to be what? Ni square divided by Nn. Nn we already know, that is this value, 2.25 times 10 to the power of 15. So Ni is already given in the question. We just have to find out what is the Pn value. Now let's go ahead and plug it in the equation. So Pn is going to be what? Ni square. So this is majority, and this is minority. Minority is holes. Pn is equal to Ni square divided by Nn. And when they say complete impurity ionization, we can, instead of Nn, we can write Na. Okay, and then Ni square is what? 1.5 times 10 to the power of 10 square divided by Na is the number of electrons we have. Okay, so this one is Nn mean this is actually Nd, right? Nd. So this one should be 2.25 times 10 to the power of 15. And if you divide this one, if you square this one, you're gonna get 2.25 times 10 to the power of 20 divided by 2.25 times 10 to the power of 15. Then 2.25 cancels. We have, if you bring this one to the numerator, 10 to the power of negative 15. So we will get 1 times 10 to the power of 5 finally, right? So that's per centimeter cube. So this is going to be the holes concentration. And that's how we do this kind of problems. I hope this helps. Thanks for watching.